data set from the startup Comma.ai on self-driving cars. In case you're not sure, they've got a GitHub page. You search Comma.ai, it's like the number 2 link. You'll see it, where they demonstrate a little simple model where you can try to steer the car just given the image. So we're going to do that, plus the acceleration and the speed, which they were kind enough to include in their data set. I was happy to see. They had all kinds of extra data. I was worried it was just going to be the images, but they have lots and lots of stuff in there. And so I just now futzed around with the data to make it actually start training a little bit, and I see it's actually doing something, which is good. I'm going to interrupt that in just a second. Let me quickly go over what we're doing. So last week, you might recall, we were just looking at the data, getting a feeling for what the heck was going on. I downloaded the whole data set, but I only extracted a few of the files because it's 45 gigs of data. I don't want to deal with all of it at once. I'm just trying to explore and figure out what the heck's going on. You can already tell this is going to take a long time to train, but that's okay. So last time we read in the data, and what I wanted to do was shrink down these images. Instead of it being like the 160 by 320, I just want 64 by 64, tiny little pixelized images. And so what we do here is we say for all the data files, grab the camera section, grab the camera file, the actual images, figure out how many we have, and start keeping track of how many we have, because I'm sort of going to concatenate all these data sets is the idea. This just strips down, shrinks those images using scipy.misc.image using a cubic interpolation. I think in this case it's going from, I strip out the widescreen edition, so we just get a square. So it becomes 160 by 160, and you convert that to 64 by 64. Maybe I should have done like 80 by 80 then. Oh well. Whatever. It is what it is. And this transpose at the end is just to line up the color channel in the place that I want it, which is the first spot. And then you read the log file, which has all the other information. It's got like speed, it's got acceleration, it's got a special tag so you can line up these images with all the log information. So you have more you're logging at a higher rate than you're taking images. It was like the images are like 20 a second and the logs are like 100 a second, I think. It's not exactly that though. The clocks aren't perfectly synced up. So you do need to check and figure that out. But it is what it is. And then I go through and I just read that. Sorry, where am I now? Oh, I line up the business here is what I do. That's all this is. You have to start at 37. The first like 37 logs are sort of just getting the car started. And then you walk through and keep track. And then all I do is make room for the data and then read in the actual data. So you can see we're getting speed, we're getting acceleration of the car, we're getting the steering angle, we're getting how much you're gassing and how much you're braking. That's all. And I see Rick Anderson made it again. That's right. So last week I didn't talk much about how the race actually went because I didn't go to the race. I didn't even know then. Last Thursday I was at FUBAR and we had the car there and we were able to futz around, do a lot of debugging. And I think there had been a problem in getting the code for the model to talk to the controller. And it was getting confused and always just turning left. So it got on the track and it went somewhere, it turned left. A lot of fighting with that on Thursday. We got that working-ish. I think it was obeying commands from the controller. The steering's not fast enough. It can only go like make a command about once a second, but it did something. And the model was finally starting to control things. So hopefully the next race, even if the model's not good, it'll at least be in charge. And we now have the car to a point where we can start to think about collecting data. How we want to do that and what data we want to collect and what we have to do to actually get that data on our hands. And I think I'm going to let this one epic finish and then I'll show you guys what's going on. So anyway, that was the last week. I compressed something like, I don't know, 8 gigs of data, maybe not that much. Couldn't have been that much. Down to about 1.5 gigs is what I ended up doing. And so this week we want to actually build a simple model with the Comma.ai dataset. If you go to their GitHub page and you check out train steering model, they actually have a small model here that you can check out. Pretty straightforward, a couple of convolutional layers, a big dense layer, and then the output. And that's all. And that's a nice simple thing to do. Rick's telling us there's turning both directions and there's time for it to complete. There is time for it to complete a turn. Okay, cool. That's super good to know. So yes, this Comma AI, this is just a model just for demonstration purposes, just to say, hey, you can make a model. Very simple, not too hard to do. I'm going to interrupt our training here. And so this model right now, I've just stolen the model from the autonomous vehicle itself, from Auto. The model, I'm training on this new data though. At some point I will load in the old data, load in the old weights that we trained before, and apply those to the new data and see what happens. So I define the model, then you read in the data here. It's pretty simple. This is, you read in all the data as a NumPy array, and then it's sort of like a dictionary. Each type of thing is I've labeled. So it's images, or the acceleration and the speeds. You have to concatenate those because they're separate things, or the actual steering angle. I'm not worried about the gas and the brake right now. And you might recognize this training code. It is almost exactly the same as when we did the old model with the deep drive data. All I changed was the steer out thing here. That's all. Only thing I changed. Is this even the right label? I don't even know anymore. Is it? Yeah, it's got this name, steer out up here. It's got the right label. We're good. So we have a simple model now. I want to try to draw a line. So steer predictions, and I want steer. There we go. So we're going to take a look at the data in just a sec, and you're going to see something strange. One of the cool thing we got while the car is driving, we got it working that it shows, we have a little monitor attached to the back of it, like a little 7-inch flat screen monitor, and it displays the image of what the car sees and where it wants to drive it live, which is really cool. I'm glad we got that working. Okay, make predictions. That's what I need. Make prediction. So I can steal that from simple steer, no doubt. Here we go. Yeah, let's do that. This might take a little bit of time. Hopefully not all the time. And then we're going to make a little video showing what our car, where it wants to drive. Get point. That's right. I need to... There we go. Prediction. That really shouldn't take all that long. I guess I could have only have done the first umpteen. Might be a little easier that way. Do like the first 1,000 or something. I'll do the first 2,000. So not all the data. Don't need to do all the data. There we go. That's a little more sane. There's like 100,000 data points in this data set now. Oh, I need auto indent off. Auto indent. There we go. Auto indent, I like it when I'm programming in IPython. I don't like it when I'm programming and then run things in IPython. Just sort of the danger of the situation. Alright, this is just the same video code that we had from before. Fun fact, this range, this frames equals business is, that was burning us when we were trying to do the actual live video. Let's see how this goes. Too many indices for array. Boo. What is steer? Steer.shape. There we go. Too many things. 0. There we go. Let's try this. Is this live? Yes, you are live right now, Mr. Yu Liang Li. Boom. So you notice this data starts off. Right now, someone is trying to back out of their garage. And I guess they have their wheel turned a little bit to the left. And you're going to see them try to get out. We're going to find out which way their steering is oriented. They might be, their steering might be oriented slightly different direction. That's one thing I want to find out. Do I need to reverse the steering in this model? So we should be able to see them. Oh yeah, we need to reverse the steering. In theory, the model should learn to match whatever it is, but I'd like it to be pointing the direction the car is actually going. Because we're going to see you're going down the road, it says stop right there, and they're probably going to turn right, is my guess. Yeah. Well, that's embarrassing. All right, let me fix this right away. Right away, my friend, right away. This is just a problem of visualization at all, really. Okay. So you start at the bottom, and you're going to P, comma, P. So what's P in this case? P is not defined, right. It's a problem with get point, right? Yeah. Int x equals this. That's just where you are in the x. It should be 1 minus this, right? Hang on. Oh, no. I should take out the 1 minus in here. That's what I do. Whoa, 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 whoa. So this is actually correct. Here we go. Where can you find a schedule of this series of live streams of data analysis? Rick's got it right there. Every Tuesday at 6 U.S. Eastern Time. If it's daylight savings in Eastern United States, daylight savings will apply to this. If there's a leap second, leap seconds will apply. All right, so that is now going. I'm going to let that play. Yes, so you point to the right because you're going in reverse. That makes sense. You don't need to teach the car that separately. And you turn to the left going forward. Okay. Well, I made some homemade root beer. That may have been a bad decision. It's got this horrible bitter aftertaste. So I just want to let this play and see. This was one epic of training that the model did. So I do not expect it to be at all good. That took like 3.5 minutes for it to go. But I want to see what it does. We're in some kind of hilly location. We're going pretty straight. There's other cars. It's the 64 by 64 pixels gives me a surprisingly good sense of what's going on. I guess this is like having like 2100 vision or something. Okay, I guess that's the end of that. Okay, I only did 2000 images, so that might be the problem there. That is all. Let's actually... I like just looking at these images. These are, to me, just interesting. Start equals 2000. Stop equals 4000. There we go. Now we will do this in a slightly more robust fashion. Start, stop. Just making sure those weren't already variables that I have. I get burned by these kind of things all the time. You'd think I'd remember which things are variables and which aren't, but, you know, I don't. Alright. And stop minus start. There we go. That should be fine. There we go. Start. That's where we want to start. Steer creds of I plus val IDX. No. That one already starts there. Silly me. Alright, let's look at a slightly different part of the data. Does it learn to stop at lines? Well, right, this model is not trying to learn stopping right now. It's only trying to learn steering. That's something that we could add, and that's something we fiddled with in the model back and forth. It might learn to stop at lines. Let me actually plot that plot. Do I have... Hang on. Because I did save the braking data. All data... brake. So there's certain places where you can see like it absolutely comes to a grinding halt, or like this is someone who's slamming on the brakes at whatever the situation is. But you might be more interested to learn, what about this situation most of the time? Like, well, so here they're doing a lot of braking. This is probably them coming out of the drive. you know, you hold on the brake a little bit, then you go mostly straight. Sometimes you stop and turn. This is someone slamming on the brakes. This is some sort of incident that occurred at, I don't know, call it 51,000 to 53,000. Let's take a look. Let's see why that data point is that way. Because I'm honestly curious now. That's half the show is just the data, fiddling around with the data. I really like models, but the data is honestly just as important. So we'll do 2,000 at a time, just so we don't look at too much at once. And let's have a look-see. So we're stuck behind a car, waiting in traffic at this point. So at some point, I guess I could have plotted the actual brake as well here. Man, that's terrible. This is almost as bad as in the deep drive data when we were stuck on a car. At least there, like, the steering was totally messed up because the AI was trying to keep going around the car. What are we at, like a toll plaza? No, we're in a left turn lane. That's what it is. So we're trying to turn. Woo! We're making a U-turn. Oh, geez. I did not know that was in here. And that was strange. Are we going in reverse? Oh, we turned into a parking garage of some kind? Who turned out the light, guys? Who turned out the lights? Yeah, this is the important question of what does your model do when you're only looking into darkness? Okay, that was everything. Huh. Yeah, so I guess we turned into a parking garage and turned out the lights and got out of the car. So that almost makes sense. Did you turn? Yeah, there's a lot of weird stuff in this data. But how your car handles weird stuff is going to define how good it really is at whatever it's trying to do. Okay, so that's actually interesting. I'm glad this model does something. It's not great. In no way am I saying it is great. But it's getting the job done. All right, something that I've been meaning to do is just moving the model over to a dang other file. Because I'm tired of that. I shouldn't have to think about this. There we go. So I'm going to define the model in a different file because I don't want all this garbage in my file here. I want it in another file. And I'll just say from model import model. Perfect. And then we can do, I'll say grab the model. And then I can grab different models if I want pretty easily by renaming the files. Or, I mean, there's other ways to fiddle with that too. Okay, so I don't need this open anymore. I don't need auto open anymore. Let's see what to work on. So now we're at an interesting point of like, well, we can decide what we want to work on with this model. Do we want to fiddle around with a neural net? Do I want to look at the data and decide what data I want to throw out more? There have been some interesting ideas from talking with different people. Some folks at FooBar. We had Jenny is one of the new people. She's really good with neural networking and machine learning stuff. We had a guy from NVIDIA who just came to check it out and offer his perspective on things, which was interesting. And I've been talking more with Isaac. He had some good model ideas. He wanted to try transfer learning, where you take one of the popular like image classification models, like BGG16 is one of the big guys because there's 16 layers. Is how it is, and there's one already made in Keras. Hey, what do you know? So this is a model that's really good at identifying objects and images and what they are, like a dog or a cat or various other things. The guy sitting in the chat, you just came to watch the first Comma video, and here I am. It's good to know I'm in the first Comma video, and you just found a live stream. You are part of the model now. Congratulations. Anyway, this VGG16, the idea is you would use this model as the initial part of your model, essentially. And somewhere, I think after the convolutions, or maybe somewhere even deeper at this like dense 1000, oh no, the dense 1000 is the outputs. After doing all the convolutional stuff, you cut off the bottom part of the model and you put your model there, and you can change what the outputs are. So the idea is all these convolutional layers are just computing some interesting features of the image that are somehow relevant. And for this model, they're relevant for figuring out, like, is this a plane? Is this a dog? Is this a bus? Whatever. But the idea is that these are sort of, I don't want to say universal features, but widely applicable features that can help you determine lots of things about your model. Maybe you can use these to say, hey, there's a dog in the picture. Maybe my car should stop. Or, there's a person there. Maybe I should turn right. Something like that. That's a very high-level view of what this really is. So VGG16 is one of those models. There's others, though. There's a smaller one called SqueezeNet. Yeah. It has far, far fewer parameters and almost as good accuracy. It might have as good of accuracy. That I might be misremembering this. But I don't recall exactly what the shape was. SqueezeNet, 64 filters. ImageNet accuracy, 80%, that's not bad. Cool. They have this cafe model, which I don't want to view the raw business of. But that's one idea, to do transfer learning like that. Another idea is to introduce the time component. So maybe you care what the image was a few seconds ago to determine what you're going to do now. You have a recurrent neural network. You could have something where you just look at all like 8 images from now through the past several seconds. That's one way to do it. Or you have a recurrent neural network. Oh, hey, Jenny here. Congratulations, welcome. You just missed, we were just talking about you. Saying you had good ideas for machine learning. So welcome, and anyone in chat or anywhere, feel free to shout in and tell me I'm doing something stupid, because that will no doubt happen, that I will make horrible mistakes. So another idea I was describing was to introduce this recurrence. Something like a long short-term memory model is a way to not only look at the previous images, but look at the previous intermediate values in your network and use those. And you use them in sort of a arcane might be the appropriate word of how you do it. You sort of want your model to know like when it should throw away information, when it should keep information, and you sort of use machine learning to do that too. We're not going to get quite that complicated just now. My main goal was to build a simple model. We did that. We built a simple model. And to... that was my only goal tonight. Build a simple model. That I succeeded in 15 minutes. That is just the nature of the business. That sometimes it takes no time. So let's just look at a slightly different piece of data while I stop and think. This will be perfect. I can think while looking at that. So this is a model driving down the highway. It's kind of daytime. It's going relatively straight. The model says go straight, probably because the model says go straight almost all the time. The red is the model, the green is the target, as always. And that's almost certainly, they're like drifting slightly left. I don't know if their steering is 100% accurate. Wow, steering may not be 100% accurate or lined up. That seems odd. I didn't update the validation. No, I did update. I didn't update the validation index. Thought I did. No, I did. So I don't know what the deal is. That's very strange. Very, very strange. They're clearly going a little right, little left. The model says, hey, go right a little bit, go right a little bit, go right a little bit. Probably because in a very similar image, they go to the right at some point because they want to change lanes. They're going to get ahead of this car, and they're going to turn to the right. I guess maybe it just doesn't take much. That did not look like they turned right, though. That's interesting. That's weird. Very strange. Very strange. That's just perplexing me. Position of car at angle going forward? Oh, that could be. That's definitely possible. Rick has a good idea. I probably have the position of the steering wheel angle, but if you turn your wheels and then you're already facing the other direction, then you sort of want to straighten out and then you turn back again to get back where you want to be. So it might not be super obvious. And these are subtle shifts, you know? And my data is scaled in a way I probably shouldn't have scaled it. Yeah, lane shifting can be more subtle, yeah. If we look at steer, you see that the steering is dominated by these tiny little shifts. We were at 27,000, about over here. There's not a lot going on. Someone else in the chat, they got a new GPU, having issues running Keras TensorFlow. Error was with cuDNN libraries? Yeah, I have the same problems. I run Keras with Theano background. That's what I do. And I can't get cuDNN to work either. I get cuDO to work, so I'm running on the GPU, but not as optimized as I could be. Yeah, so you've got these very subtle differences, but it's dominated by these like huge, like these are wide turns where you're turning as much as you possibly can. Like wherever it was, 30-some thousand. Yeah, like this is where you're turning into that parking garage or something. So I chose to scale it, everything 0 to 1. It may have made more sense to scale by like the standard deviation. And then you might see more things like this. And that might inform the model a little bit better. Because most of the time, we're just not doing that much. But like it makes a big difference. And so this might just be, visually I need to scale this better. Or like, maybe that's okay. Maybe just a little subtle shift. Maybe that's all it takes. These are not quite philosophical discussions, but discussions of what is your data actually, and how do you translate your data into what makes sense for the model, and how do you translate the model back into what makes sense in the real world. Those are all kind of problems that you have to deal with. All right, but I'm going to take a look. Where's... Yeah, okay, I stole Isaac's model. And by stole, I mean he showed me his model. He was kind enough. And he had a slightly different model because he made the images grayscale. So he cut his data by like a factor of 3 right there of things he has to worry about. Because it doesn't have 3 colors now. It's like, pretend you're a dog driving. You can only see black and white. That's probably not his thought process, but that's how I like to imagine how it happened. I want to see if I can get that working in this new data set. So he's got... Which one of these? Is it this one? His model. That must be his model. That must be correct. Do I have my model over there? Oh, no. Okay. He's got a lot of things here. Here we go. Let me just... Yeah, that's not what I want to do. Not what I wanted to do. Undo that, undo that. Redo that. Hang on. Hang on a second. He shuffles the data, he does all this, he does all that. I'm trying to debate how to handle that. It's a different set of things. Move model.py. Auto model.py. There we go. Auto model. I like the sound of that. That's cool. And then, okay. Then I want to copy Isaac's model into here. There we go. And let's link a symbolic thing that exists, thing that you're making. There we go. Now it's all good. Now it's all good. Okay. Yes, this is exactly what I wanted. I didn't want to deal with data in this set. But I do need to make stuff grayscale. That's all. Okay. Yes, here we go. Sorry, I just need to futz around, move things around, figure out what the heck it is that I'm doing. Like you do. Images color equals this. images, however, images, color. There we go. Let's do that. It's gonna take a little time. Oh. Well, I've joked about it, but I think this root beer might actually be growing on me. Or it's like it's less foul the more I drink it. That's what it feels like, anyway.